Assalamualaikum and hello everyone. Welcome back to a new video of chapter 4, which is 4.5 metallic bond. Metallic bond will be the last subtopic of this chapter. So hopefully by this video dah habislah this topic. So here, first what we're going to look at is actually explain the formation of metallic bond by using electron C model, and then we're going to relate the metallic bond to the properties of metal, which is malleability, ductility, electrical conductivity, thermal conductivity, explain the factors that affect the strength of metallic bond, and relate the boiling or melting point to the molecular structure, type of bonding, and intermolecular force. Okay, so first one kita akan tengok is actually metallic bond. Okay, previously we have looked for the case kalau kita ada metal dengan non-metal, that is actually kita punya ionic bond. That is our ionic bond. And then we also look case of between non-metal dengan non-metal, where they share the electron kan. So that is our covalent bond. Sekarang ni kita akan tengok bila case between metal and metal. So the bond is called metallic bond. So what is metallic bond? Is the electrostatic force between the positively charged metal ion and the sea of delocalized electron. Okay, so for the electron C model is that you have to draw. So is that you have to draw the ion, okay, the metal ion lah, and then the electron. Ni positive ion ni sebab our metal has donated the electron kan. So once it donated the electron, so it become positive ion ataupun our cation. So and then once it donates the electron, so yang ni dia panggil ni valence electron kita. Delocalized ni maksud dia mobile, it can move around. So contohnya for the case of our sodium, so when we draw it here, our sodium ni sodium tu buat sodium plus, and each of our sodium plus ni mesti ada 1 electron. So when we count, the number of sodium plus dengan number of electron dia sama. Sebab kalau equation for sodium will become Na plus electron. Okay, so kalau magnesium, so for magnesium will become Mg2 plus dengan 2 electron. So, when you draw it here, make sure that for each of our magnesium ion kena ada 2 electron. Sebab dia dah donate 2 of our electron. So, kat sini kalau kita tengok aluminium, for each of the aluminium, it will donate 3 of the electron. So, dia akan jadi Al, akan become Al3 plus 3E. So, make sure, the number of electron tu, dia mesti samalah sebab Al3 plus donated 3 electrons. So each of the atom mesti ada electron. So the electron is moving around. So it's mobile. It can move lah. Sebab tu dah dia panggil the sea of delocalized electrons. Sebab banyaknya electron tu. Okay. So when you draw it, make sure labelkan. Nanti label lah. This is our electron. Delocalized valence electron. This is our positive ion. So that is the metallic bond, which is the electrostatic force between positively charged metal ion and the sea of delocalized electron. Okay, next, from the properties of the metallic bond tu, kita akan tengok what is the properties of metal. So malleability. Malleability tu, it means that our metal tu can be shaped. It can be hammered. Yang ni macam dia tengah hammer kan, dia tengah shape kan dia. Okay, so why it can why it can be shaped, so even though it's very strong, sebab dia ada very strong electrostatic force kan, so sebenarnya it has a higher boiling and melting point. However, even though it is very strong, tapi dia senang untuk dibentuk. Why? Because the electron tu, the delocalized valence electron tu, makes that the metal ion can glide past each other. So that's why lah, our metal ni can be shaped or hammered. Malleability lah. Okay, and besides that, it also give rise to the properties of ductility. Ductility tu, it means it can be shaped into a wire lah. So kat sini malleability bila kita bentukkan dia. Ductile ni maksudnya kita nak make it into a wire. Maknanya it can be shaped. So it is due to the delocalized electron. Because the adanya electron ni, the mobile electron, the metal ions can glide past each other without breaking. Okay, next one kita akan tengok is the electrical conductivity. So, electrons are mobile, so it can flow towards the positive electrode when a potential difference is applied. So when we apply voltage, for example, plus ni is actually our sodium lah. For any of our metal ion. Contohnya ni M plus lah. Contohnya. Okay, and then we have our and we have our delocalized electron. We have our valence electron. So, for example, when energy is applied, since the electron is negatively charged, okay, electrons will flow towards the positive electron. So, what will happen? It will conduct the electric. So, that's why it is called electrical conductivity. And last but not least is the thermal conductivity. So, sama juga, since it is mobile, it can transmit heat easily by carrying kinetic energy from hot to cold. So, dekat sini kita tengok heat conductivity. So, the movement delocalized electron facilitate thermal conductivity. So, sebenarnya the C of delocalized electron ni give rise to the properties of metal. So yang ini memang simple sajalah. Nak explain banyak pun tak ada banyak sangat nak explain. Okay, next one what we're gonna look at is actually explain the factors that affect the strength of metallic bond. Yang ini lah. Okay, so kita tengok dekat sini. So what is the factors that affect the strength of metallic bond? First is actually the number of valence electron dengan atomic radius. So kat sini kita tengok the strength of metallic bond is directly proportional to the number of valence electron, but is inversely proportional to the atomic radius. So contohnya kita tengok dekat sini, this is actually all the elements in period 3. So dekat sini for our sodium, we only has 1 valence electron. Magnesium ada 2 and aluminium ada 3. Okay, so kita tengok dekat sini, iaitu NaMg dengan Al. Yang gini, kalau period tu, dia jadi lithium, beryllium, boron. Okay, so kita tengok dekat sini, if it has 1 valence electron, dia punya boiling point is 1330. Kalau tu, dia jadi 2000. Kalau 3 jadi 3000. So, as we can see, the higher the valence electron, the higher lah the boiling point. The same goes for element in period 2 ni juga. Bila kita tengok, the higher the number of valence, the higher the boiling point. Okay, so how do we explain it? Across the period, the number of valence electron increase. So, the strength of metallic bond ni pun increase. More energy is needed to overcome the attraction, the force of attraction, hence the boiling point increase. So, dekat sini, so samalah kita tengok dekat sini kan. So, ni, the ionic charge increase, okay, attraction will increase. Sebab, bila kita dah banyak lagi elektron kan, contohnya sebab kita tengok, yang ini hanya ada satu sahaja, 1-to-1 ratio. Yang ni, elektron dia lagi banyak kan. Sama juga, dia punya positively charged tu, higher positively charged. It has a higher positively charged ion, and it has a higher number of electron. Okay, so that's why lah dekat sini, bila lagi banyak valence electron, lagi tinggilah kita punya force of attraction. So, positif dengan negatively charged tu, dia banyak lah kiranya. So, that's why lah. Okay, so that's in terms of the case of valence electron. How about the atomic radius? Okay, so contohnya kita tengok in group 1 itself, semua ni memang maksudnya all the valence electron is 1. Tapi bila kita tengok down the group, you still remember the N size. Down the group, higher number of shell, higher shielding effect, lower of attraction between valence dengan between the valence electron and the nucleus, has the size increase. So kita tengoklah radius ni kan, picometer. Down the group, the size increase. Okay, tapi kita tengok boiling point, down the group, dia decrease. Okay, why? Okay, down the group, the atomic radius decrease. Okay, and the strength of metallic bond pun akan decrease. Hence, less energy is needed to overcome the force of attraction and... Kenapa, Mak? Tak apa, saya cakap kat sini. Okay. Okay, less energy is needed to overcome the force of attraction. And then the boiling point pun akan decrease. Okay. Because actually when the size is getting bigger, tapi the number of electron dia sama sahaja kan. So what will happen is that the force of attraction tu will become weaker. So that is actually for the case of strength of metallic bond. So it is directly proportional to valence electron. Sebab memang lagi banyak elektron, lagi dia suka lah kan, lagi strong lah the attraction between our positively charged ion dengan elektron. Tapi dia inversely proportional to our radius. So bila our radius is getting bigger, tapi the electron tu pun sama sahaja kan. So it has a weaker force of attraction. So that is actually factors that affect the strength of metallic bond. Okay, last but not least, yang summary. Okay, the melting and boiling point across period 3. So this is actually what we have learned lah sebenarnya kan, across yang chapter 4 ni juga. Okay, so across period 3, we have our sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay, so for these three is actually our metal. So metal ni exists as metallic structure. Hence, the intermolecular force will be metallic bond. Okay, remember that the strength of the metallic bond depends on the number of valence electron. So the higher the number of the valence electron, the stronger the metallic bond. Okay, when the stronger the metallic bond, hence it will the higher the boiling point. Okay, so the order of increasing boiling point, kita tahu sodium ada satu saja, magnesium has 2, aluminium has 3. Then the order of increasing point pun boiling point pun samalah, Ne, Mg, Al. Which is when we look, memang tengoklah from sodium to aluminium is getting bigger, is getting higher boiling point. Okay, for the silicon, okay, next is silicon. Silicon is a metalloid where it exists as giant molecular structure. So actually, for the silicon itself, it has covalent bond. Okay, silicon has the highest boiling point. Why? Each silicon atom is tetrahedrally bonded to other 4 silicon atom with strong covalent bond. So bila dia dekat sini, bila kita tengok, semuanya it's bonded, tetrahedrally bonded to other 4 silicon atom. Okay, so more energy is needed to break the covalent bond because silicon is in the giant covalent structure. So, the structure yang sangat besar. So, that's why lah memang kita perlukan energy yang sangat tinggi. We need a higher energy kalau kita nak break the bond between the molecule itself. Okay, last but not least is between our phosphorus until our argon. So, this is actually our non-metal. And then, this is actually our non-polar molecule. Okay, so, argon ni mana? Ar molecule. Sebab dia memang sudah capai noble gas kan. So, Ar molecule lah. Chlorine ni, dia exist in Cl2. Sebab each of the chlorine kan has 7 valence electron kan. So, each of the chlorine will share 1 valence electron to form Cl2. Okay, kalau sulfur, ini is in, dia form, dia punya, stable structure, is actually S8 molecule. Kalau our phosphorus, dia adalah P4. Okay, so contohnya dekat sini, van der Waals force depends on the size ataupun molecular weight of the molecule. Okay, so, sebenarnya, the higher the size, kalau size tu sama jugalah dengan molecular weight, the stronger the van der Waals force. The stronger the van der Waals force, the higher the boiling point. Okay, so here is actually the size. Argon 39.95, chlorine Cl2 69.94, S8 is 256.5. Sebab dia ada 8 kan. And then our P4, our phosphorus 4 ni 123.90. Okay, so kita tengok dekat sini. So the order of increasing molecular weight. So the low order of increasing maknanya kita start dengan the smallest to the biggest one. So start with our Ar, our argon. Next is our chlorine, and then our P4. And last but not least is actually our S8. This is the order of increasing size. Hence, the order of increasing boiling point pun sama sahaja. Kalau between all our metal, kita akan tengok in terms of metallic bond, in terms of be it valence electron ataupun the size of the atomic radius of the metal. Okay, kalau in terms of kalau yang non-metal, kita akan tengok in terms of van der Waals force, ataupun senangnya kita akan tengok in terms of the size. So, that's it. The last of chapter 4. The last of chapter 4.5 and the last of chapter 4.